Let's discuss hydraulic fluid analysis and how on-site analysis can be used to monitor hydraulic systems. So let's have a quick overview of what hydraulic systems are. What we're doing is a hydraulic system, of course, is an incredibly efficient and compact system that's used where liquid is used to transmit power. So on a typical hydraulic system of any sort, you can have some sort of system that's being worked. Here in this case, like an example would be a cylinder, quite common on an excavator or on an industrial piece of equipment. You've got some sort of a control valve, you have a reservoir for fluid, you have a filter, and you have a pump. And so this system is being used all the time. The fluid is being forced up by the pump to be able to drive the item that you're working with. The big concern we have is, of course, is that the fluid is the lifeblood of the system. So we want to make sure that that fluid is meeting its operational requirements. Hydraulic fluid is generally selected. It's typically a hydrocarbon-based product, but not always. It's chosen for its viscosity, because you need that for transmitting power. It needs to be a low viscosity, stability, heat removal, antioxidant, long life. These are why we choose fluids. But what are we worried about? Well, we use fluid analysis and oil analysis to monitor the quality of hydraulic systems because the predominant failure for a hydraulic system is related to contamination. There are two major types. The most predominant is solid contamination, i.e. particles or wear particles getting in, or liquid, water, or some sort of other rare process fluid. All hydraulic providers of any type will provide some sort of limits or alarms to make sure that these levels of contamination are controlled. Usually they form them and there's some sort of a contamination code, be it from ISO, NAS, SAE, there's a variety of different societies. And so most providers of hydraulic systems and the filtration systems that work for that will talk in terms of these contamination standards in terms of a way of controlling the level of contamination that's getting into the system. So typically if you hear of ISO 18163, that is a pretty much a common cleanliness standard that all hydraulic systems need to be below for proper operation. That's important particularly for solenoids and valve systems, and other types of systems may allow for more relaxed levels. A rule of thumb is that the higher the number in all of these classes, the more dirtier the system is. So we all talk about that. It's good for you to always be aware of what microns are. You typically select filters based on micron size. Of course, 1 inch is 25.4 millimeters. A human hair, the average diameter is 90 microns. 40 microns is about the smallest a human eye can see. But in terms of particle counting, we're dealing with 4, 6, and 14. For greater than 4, greater than 6, greater than 14. And servo valves or actuator clearances that are typical in most hydraulic systems nowadays have clearances anywhere from 10 to 80 microns in size. So you can see that we're dealing with very, very clean systems as a rule. So why do we monitor and what do we monitor? Well, the major applications that you'd have hydraulic systems in, they're pretty common everywhere, but aviation, industrial, mobile systems all have hydraulic systems. One comment is that for aviation systems, because of the environment and the location, fire-resistant phosphate ester style fluids are fairly common in those applications, and so they need a specific, you do need to worry about water and contamination, solid particulates, but you have to be aware of the type of fluid you're dealing with. For industrial applications, mineral is most common, but you do see what we also see is synthetic hydrocarbons coming in quite common. And then in mobile applications, predominantly it's mineral-based hydrocarbon oil is fairly standard, straightforward oil. Why do we care about the monitoring? Well, we always monitor, as we said earlier, for particles, and we want to compare that to known OEM limits or alarms. We want to control the water content, keep that ideally under 2500 ppm. Or less depending on the application. Higher water leads to potential corrosion problems and leads to problems with transmitting power. You always want to keep the viscosity of the oil within its operational oil specification limits. A heavy oil will cause problems. You want to keep it within a certain range. Elemental spectroscopy is good to determine the source of the particles if you have an elevated particle count. Also good for determining additive levels. Acid number is very helpful for hydraulic systems because, and as well as oxidation by IR, because it basically helps you to determine if the oil is aged. If the oil is starting to break down, you can have some sludging, you can have things known as stiction showing up on and as well as varnish showing up on servos and reservoirs. And of course, optional always is wear debris analysis or ferrous particle analysis to be able to identify the shape of particles in order to find the sources. So what are the best tests that we should do? Particle count always on any hydraulic system. Cleanliness is next to godliness when it comes to the quality of hydraulic systems. Always do a water analysis to determine the level of moisture content. Always check the viscosity to make sure you've got the right product. Do an elemental wear in order to look at the source of the particulate that's present. Acid number and oxidation to identify the level of breakdown that's present and if the oil is still continued fit for use. And then ferrous particle or wear debris analysis as option for root cause analysis. For aviation and industrial systems, we recommend that you look at the mini lab solutions because they have all the tools for that type of environment, and the mini lab is able to handle phosphate ester type fluids that are often seen in aviation and some power generation applications. Mobile systems, microlab family of products is an ideal solution there because it is able to hit all the major elements there that you need to be able to identify if there's any problems showing up.